My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. You are watching 120 Days to Jamb Physics with Flash Isaac. In this episode, we shall be looking at energy stored in capacitors. Calculating energy stored in capacitors or in a capacitor is something very easy and is something not difficult, especially if you watched the previous episode where we looked at capacitors in series and in parallel. If I give you a question, whether one capacitor or more than one capacitor, and I say find the energy stored, these are the formulas you should use. Energy stored is half QV. You will be given the charge on the circuit, then or the charge on the capacitor. You will be given the voltage or the potential difference. If you have the two, multiply and divide by 2. Also, if you have the capacitance and you have the potential difference or the voltage, C times V squared all over 2, you've gotten the energy stored in capacitor. If you are given the charge and the capacitance, the charge square divided by 2 times the capacitance, you've gotten the energy stored in the capacitor. It is a very, very simple and interesting concept. So, this is what you should understand, and we shall look at 1 or 2 questions under energy stored in capacitors. But this is something you should take note of. In energy stored in capacitors, if you are given capacitance in microfarad, make sure you convert to farad. If I say, okay, if you are given 2 microfarad and you are solving for energy stored in capacitor, you simply say this is 2 times 10 to the power minus 6 farad. This is what you should use to solve. And the unit of energy is joules. So even in capacitors, the energy stored is in joules. A capacitor, 8 microfarad. C is equals 8 microfarad. Is charged to a potential difference of 100 volts. Potential difference is equals 100 volts. Now, if you are given a circuit and you have something like this, you see that this is of higher potential and this is of lower potential. So here and here, they are the difference in potential, and that is the voltage. So here is 100 volts. And current will move from this place of higher potential to lower potential. So the voltage is 100 volts. And what is the question? Calculate the energy stored by the capacitor. Since we have V and we have C, the formula that allows us to use C and V is half CV squared. So E equals half CV squared, and that is 1 over 2 times. Don't forget, I said you must always convert your C to farad by multiplying by 10 raised to the power of minus 6 to have 8 times 10 to the power of minus 6 times voltage squared, that is 100 squared times 100 squared. This is simply 8 divided by 2 is 4. 4 times 10 to the power of minus 6 times 100 squared, that is 10,000, and 10,000 is 10 raised to the power of 4. So times 10 to the power of 4. In this, it says that if the bases are the same, add the powers, so long multiplication is concerned. So 10 raised to the power of minus 6 times 10 raised to the power of 4 is the same thing as picking one of the 10 and saying minus 6 plus 4. So we have 4 times 10 raised to the power of minus 6 plus 4. And if I am correct, that should give you 4 times 10 raised to the power of minus 2 joules. That is the energy stored in the capacitor. Before I proceed to the next or the last question, because almost all the questions require your substitution skill. That is all, nothing much. If you are given many capacitors, you will find the equivalent capacitance, then you substitute. Look at this thing I jotted down here. It says, to charge a capacitor, connect the plate to a battery for some time so that the electrons are attracted by the positive terminal of the cell and drifted towards one of the plates, leaving positive and negative charges on the plate. Only half of the total energy supplied by the battery is stored in the capacitor. Look at it. Finding energy stored in capacitors, you see half. It shows that only half of the total energy stored. It means that only half of the total energy supplied by the battery is stored by the capacitor. The remaining half is mainly converted into heat, while the rest is radiated as electromagnetic waves. Now you see your circuit, when you are charging, it's heating up. So not all the energy supplied are being stored, only half is stored. The rest will dissipate as heat and as wave. And about discharging a capacitor, you simply bring the plate into contact using wires so that electrons can flow back around the circuit and neutralize the positively charged plate and the charges on the two plates. And discharging of capacitors is usually accompanied by sparks. The energy stored in capacitor is referred to as electrostatic potential energy. That is the name for energy stored in capacitors. Now take a look at this question. We are asked to look for the energy stored in the capacitor. We have two capacitors connected in parallel. For capacitors in parallel, the total capacitor will simply be their sum. So CT is 2 microfarad plus 3 microfarad, and that will give you 5 microfarad. We are given the potential, that is the voltage across each capacitor, to be 100 volts. And you see that since they are connected in parallel, the same voltage is actually flowing through them. The energy stored will be half CV squared. That is 1/2 times 5 times 10 to the power of minus 6 times 100 squared. That is basically your answer. Probably 2.5 times 10 to the power of minus 2 or so. So basically you have either the charge or the capacitance. All these things, just answer the questions. If you have any question you feel is giving you issue, let me know. Ladies and gentlemen, with this, we come to the end of this episode.